this video, we will take a look at the Nvidia Blueprint IQ for enterprise research running on top of HPE's private cloud AI. As you may already know, HPE's private cloud AI is a turnkey solution co-engineered with Nvidia, providing you with everything you need for AI: compute, storage, networking, GPUs, and of course, software as well. Here we can see the user interface of private cloud AI software layer AI Essentials. For now, let's skip over to tools and frameworks. Here we can see all the frameworks that are natively included, as well as some additional frameworks imported in this instance. This imported framework here is the Nvidia IQ Blueprint. You can import a framework by clicking this Import Framework button and following the wizard that leads you to uploading your Helm chart. In our case, the Helm chart of the IQ Blueprint. Nvidia has built this blueprint for providing an end-to-end workflow to connect an AI agent to your enterprise data and use a reasoning model to conduct research that usually takes hours within minutes. So let's dive in and see what that looks like. Here we are in our IQ Blueprint. As a first step, we decide for a reasoning model, in our case the Llama Nemotron Super. The next step, we can decide between choosing a custom collection, so providing your own data sources, or we can use one of the two preloaded collections. For today, let's use the bare medical dataset, but we want to adapt the report structure a bit. So instead of a medical researcher, let's change this first to a family medicine practitioner with a background in cystic fibrosis to give it a different setting. We want to have a report still, but it should not analyze how CFTR modulators can be used to restore those protein functions, but we wanted to analyze how it can affect the patient's life, describe ideal treatment schedule, what it entails, and whether any social or environmental factors can affect patients' health. Also, what are the best ways to manage lung health? Of course, we still wanted to consider all but only relevant data and result in a factual report with cited sources. So let's go ahead. We can also select web search additionally, but therefore you will need to provide a Tavily API key. Let's start generating. So as a first step, the reasoning model will think about the task we provided. So what are the different steps to get the results we asked for? So it evaluates different approaches to tackle this. So here we can see the result. It decided for a plan to first get into cystic fibrosis overview, then into treatment, and at the end, social environmental factors affecting that. So we can decide if we want to execute the plan, and of course we want to do that. It will take some time, but in the meantime, we can watch what it is doing exactly. So we have several steps. As a first step, it will look up into our enterprise files, so into the biomedical collection we provided it with, what information it can find there. It will check the relevance of those information pieces, so of our data sources. And also it will add a web answer to include some web information available as well, especially if it's not happy with the answers it found in the RAG enterprise research. Then it will summarize our sources. It will run a summary of all of these summarized sources, and currently it's reflecting on the summary. While it does that, let's take a look at the blueprint card. So here we can see some more information regarding this blueprint. For now, let's focus on the architecture. So we can see here that we have as a first step what we've already done, a user or a machine sending a prompt. So this was our instruction to create a report. We sent this to the agent. The agent then uses the reasoning model, the Llama Nemotron Super, to plan what it should do. So this was like the plan we've seen. It was thinking back and forth how to handle it best, decided for a plan, and then we could click executing the plan. What it's currently doing is it's checking the enterprise files. So this one is referring to the RAG enterprise blueprint of Nvidia. And there it will search in the collection in the vector database the information that is relevant for answering our question or instruction of creating a report regarding the cystic fibrosis. In addition, it has the ability to use a web search tool to add even more information pieces to the puzzle. It uses all of that information to create the report, and the report generation is using actually a different model, a usual LLM, in this case a llama. And then at the very end, we will get back a report to the user, which we can refine, we can download, or we can also chat with the report to answer our questions. With that, let's jump back to our experience. And we can see we have the final paper here already. As we have instructed, it starts with an introduction. So, cystic fibrosis is a recessive genetic disorder caused by mutations in the CFTR gene. We have here also more information regarding the impact on patients' life, for example, lung disease. We have the ideal treatment schedule, the social environment factors affecting health, best practices discussion, and the conclusion. And here we can see all of the sources that have been used. So those are different documents within our collection we have available. And we can download this result as a PDF, as a Markdown. We can edit this report if we are not happy with it, or we can also chat with the report. Hopefully this was a helpful demo, informative of the Nvidia IQ blueprint for enterprise research, and also how to run this on HPE's private cloud AI. Thank you.